Okay, so quick video today. I'm not gonna be able to sit still very long. I may have hurt my back a little bit. I'm getting old. Okay, so despite this being a short video, hopefully, I think it's gonna be a very important one. I'm gonna start with this code here that more or less answers a quiz question about bootstrapping, but I'm gonna use it to talk about a coding principle, sort of a general one, and some R specific nature of it. Okay, so obviously, this code was posted because there's something wrong with it, so we're going to run it, check it out. Let's see here. Where's my cursor? There it is. Okay. And we get an error. In particular, an error, so didn't even run. And well, because of the order the code ran in, you should probably have a pretty good idea of where this error occurred. I want to talk about the error message for a second here. So one thing that especially newer R users complain about, and it's a perfectly valid complaint, is that the error messages don't really help. And I totally understand that. I can read this error message and have an idea of what it means. There's sort of like two key things in the error message. It tells me that there was an error when we ran this function, this sort.int, and I don't know what that function is, but I'm guessing it sorts integers. And you might realize, well, we didn't explicitly use the function anywhere, but if you understand everything that's going on here, you might be like, well, I can see why we would have sorted something at some point. So we realize that one of our functions is calling this function and it's tripping an error. And then the sort of even more cryptic error is this x must be atomic. And that means something technical, but I'm going to try to explain it at a slightly higher, more abstract level. So in one of the previous videos I talked about debugging, the thing I really stressed was run each line, check what it does. So I guess I'm going to do that here. And I'm going to do it first just to find where the error is, even though I think we already know. And then I'm going to go back and sort of talk about why I'm doing what I'm doing and what I'm looking for. Okay, so I'm actually going to clear my environment too, just to be safe. Okay, so load that package, even though it was already loaded. Set the seed. Okay, that's cool. That worked. That worked. That worked. Looks like we wrote that function correctly. That worked. That worked. That did not. Okay, so we know the error is here. So something went wrong with this quantile function. So what I need to do then is say, well, what do we have here? Big hint, this is where the problem is. But I want to sort of explain that. And to explain that, we're first going to discuss this quotation here from John Chambers, one of the creators of the R language. So I forget I think he wrote this in one of his books, but he said, to understand computations in R, two slogans are helpful. Everything that exists is an object. Everything that happens is a function call. So I want to first reread this code with the second thing in mind. Everything that happens is a function call. So what does he mean by that? Well, let's go line by line. Comments not included. So here we have the library function being called, and we are passing the argument per to it. There's actually something funky with this function, but that's for a totally more advanced class about R. This line, we are running the set.seed function with this value being passed to the first argument. Here, we are running the data function with this character string of vector of length 1 being passed as the first argument, and then this argument package equals caret is the second one. Here, we're running the as tibble function from the table package, and you might be wondering, well, what about this? So the equals is an assignment, but that is technically also calling a function called assign, more or less. It doesn't look like a function call, but it is. Here, we're running the create resample function from the caret package. Here, we're running the... I don't want to get crazy here. Here, we're writing a function. So we're not necessarily running a function, although there are some functions being run here, but that might be too in-depth of a conversation. I want to keep it high level, heuristical, and useful. Here, we're running the map function, which internally is going to be running this make boot resamples function that we wrote. Here, and then again, assignment. Here we're running the map function, which is running the mean function, and here we're running the quantile function. So that's this, everything that happens is a function call. And then everything that exists, what it means to exist in R might be a little hard to explain, but everything that exists is an object. And we mean everything. So this library function, that in itself is an object that exists. This per, technically, I'm going to put it in quotes like I normally do. I normally do that. So this is an object. It is a character string. So it's a vector of length 1. The set.seed is a function. This number is an object. It's a vector of length 1 storing that value. Function, that's an object. Vector of length 1 containing characters, that's an object. This, again, vector of length 1 is an object, and so on and so forth. So I want to add my own follow-up to this statement, which would be this. Inputs to functions are objects. Outputs of functions are objects. And I'm sure there's edge cases where this is not true, but this is what I want you to think about when you're writing R code. Basically, every line of R code, you're writing a function, you're telling it specifics about the function, that is, you're giving it arguments, which are itself objects, then that spits back an object. So the questions you want to ask yourself for every line of code is, what objects does the function that I'm running expect, and what do I expect to get back? And so within Stat 432, I think it's safe to say that there are 4 types of objects that we are going to encounter. I'm not going to go into specifics here about what are the possible types of objects and data types and data structures in R. If you're interested in that kind of thing, you want to go back and read R for Data Science and Advanced R. They'll go into the very nitty-gritty details of this. But I sort of want to operate at a high level and say we're going to deal with vectors, lists, functions, and model objects. So that would be like a model object would be the thing that's returned when we call LM, or the thing that's returned when we call GLM. So those are basically objects with a particular class related to the model. I don't even want to talk about classes all that much, but they're things that exist, and that sort of helps define an object type, but I don't want to get into the weeds here. But basically what I want to say is every function that we run is itself an object, but every function we run is going to be passed some combination of vectors, lists, functions, and model objects. I think we'll see these 3 in this example, no model objects, but you can obviously imagine that, we very often store a model and then pass it to another function, like especially the predict function. So let's break apart, let's say, this line of code here, right? So we're running the map function. So what are the inputs to the map function? So something you generally might want to do, sometimes RStudio is too helpful. I want this. Okay. So the things I just talked about there, this idea that inputs to functions are objects and objects, or outputs of functions are objects, often what type of objects are inputted and outputted are defined in the documentation. So let's have a look. So here we're talking about the map function from the per package, and it says, blah, blah, blah. Okay. So in particular, map always returns a list. That's actually very important to what we're talking about right now. But so this map function, it returns a list always. Okay, cool. And so we see that there are inputs here, .x and .f. .x is a list or a vector. Okay, that's good. And then .f is a function formula or a vector. We're just going to say it's a function because that's kind of this formula gets converted into a function, so we're just going to call it a function because we didn't talk about formulas, but they're just shorthand for functions. Okay, so if we think about what's happening here, it said that, okay, .x has to be a list or an atomic vector. Let's have a look here. Well, this looks like a list to me. We could check that with is.list, resamp next. Okay. Also, if we look up here in our environment, resamp IDX. It is a list. Okay, cool. Good. This is a function, and this is technically making a formula, as we said about. So that's good. And then if we read more carefully, this is going to be whatever is here, so that's okay. This is a vector, which seems reasonable to input to this function. Okay, and then importantly, it said that it returns a list. So if we look at what's here, it'll be a list. Again, so that's boot resamples. We see that it's a list. We could even check that boot resamples. Cool. So, and then we sort of see the same thing here. So I'm not going to go through that again, but map, we expect the first argument should be a list. We checked that already. The second argument should be a function, which this notation is shorthand for a function. Cool. That's what we expected. And again, highlighting the important bit here, let's scroll up so you can see it. Map always returns a list. So what's stored here? It's a list. Okay. So that means this here is a list. Let's have a look at this quantile function. Okay, produces quantiles, yada, yada, yada. Arguments. First argument, numeric vector. Uh-oh. This is numeric, but this is a list where each element of the list is a single numeric, a vector of length 1. This is a list. This argument wants a vector. Similarly, this probs argument wants a vector, but hey, that's what we got. So basically the problem is that this is a list, but it needs to be a vector. I mean, this is a really long-winded way of saying this, but I think it'll help your mental model of like what's happening when you run and write our code. So the trick here, I think, is if instead of the map function here, we use the map to double. So these functions here return vectors of the particular type, that is logical, integer, double, or character. So we want a numeric double. So if I change this to be double, what we get back is a vector. Testing for if something's a vector is a little bit complicated, but we technically need to use is double, and it is. Okay, you'll have to read advanced R to understand why I'm using that instead of is.vector. The problem with is.vector, I think, is vector doesn't necessarily mean what we're using it for here. I believe that this is going to return true. Yeah, because technically lists are a specific type of a larger class of vectors. So when I'm referring to vector, I'm referring to vectors of logicals, integers, doubles, or characters. But that's something for a much more deeper dive into R. Okay, so that's a really long-winded way of saying run the code line by line, check the inputs, check the outputs. But now we have a better idea of what we're looking for in the inputs and outputs. In particular, are the inputs the correct object types, and are the outputs the object types that we think they are? Like, we should be aware of that. So again, this seems like two really trivial things to say if you've been programming for a long time. But I mean, this is maybe a little bit more specific to R, but I think this is something that you really, really, really want to internalize. I think, I don't know. I just think there's this light bulb moment that happens when you realize that the program just does what you tell it to do, but there's some constraints on that. Like, functions are written to do a certain thing. So if you it's like, I guess like when this was a list instead of a vector, it's like trying to fit a square peg in a round hole. You just can't do it. So as long as you put the right shapes together, it'll work, but you have to follow the rules and you have to know the rules. So it helps to look for, what inputs are expected of the function and then know what it's actually returning. Yeah, I guess I just really want you to get into that habit of running each line of code. I know it seems like it's tedious and that it would be faster just to write it, assume you know what happens, run it, and get the answer. And when that happens, that's great. but I still maintain that if that's how you write your code, even if you're right most of the time, those times where you're wrong, it's going to spend a lot more time to debug it than had you done this exercise of running each line, thinking in the way we discussed here. So this is my appeal to thinking about doing programming that way. Okay. And I think eventually you'll start to just think in those terms when you write code. I know I don't know when it happened, but that's kind of where something clicked with me, and I was like, oh, I really understand R a lot better. Like, I don't know everything there's know about R. That there's a wide array of functions I've never heard of. I'm not a great programmer, but I have that mental model for what's happening, so I can at least analyze the code in front of me, find the error with it in general. Okay, so yeah, I rambled way too long just to say these things, but again, I think if you keep this in mind, you'll be on the road to becoming very good at the R programming language. Okay, as always, I don't know how to end this, so if you made it to the end, good job.